Hello, everyone. So, we're going to be learning chapter 9.2, measuring angles and arcs, still working with those circles. We're going to be identifying central angles, major arcs, minor arcs, and semicircles, and we're going to define their measures. We're also going to find arc lengths. So, just like any other polygon, I guess, circles are made up of angles, and the measures, or the sum of the measures of the angles of a circle, is 360 degrees. The angles all stem from our center point and are either created by the radii or different diameters. So that's going to help determine our angle measures. Again, the sum of all the measures of an angle is 360, kind of similar to the concept of the sum of all the measures of a triangle is 180 degrees, except circles is just 360. So we're going to use that information to find the value of x. First thing I want you to notice is what's missing, right? So we have 6 angles here. 1, 2, 3, 4, 5. 5 angles here, and we're missing one of them. We're missing angle QTR. So because we're missing that angle, that's kind of going to mess up the fact that we have 360 degrees total in a circle, and we can't just name that angle x because we don't know what x is. So what you can notice is that RV is a diameter, and it cuts the circle in half. So we're missing an angle, however, we're given the measures of half the circle. So RV is our diameter, and it cuts the circle in half. That's what we call a semicircle, and half of a circle would equal 180 degrees. So that means we can add angle RTS, angle STU, and angle UTV together and equal them to 180 degrees. Notice that all those 3 angles are not all called angle T. We have to use our angle naming rule where we use 3 different variables to name the angles. Otherwise, we're not going to be able to differentiate between each angle. So I'm going to set up my equation as the measure of angle RTS plus the measure of angle STU plus the measure of angle UTV equals 180. And I'm going to go ahead and substitute those measures in. I'm going to have 8x minus 4 plus 13x minus 3 plus 5x plus 5 equals 180. I'm going to combine my like terms. So 26x minus 2 equals 180. I'm going to add 2 to both sides, so that 26x equals 182. And then I'm going to go ahead and divide by 26, and I'm going to get x equals 7. So our value for the measure of x is 7. Please make sure that you guys are writing this down in a notebook, this example, because you're going to try one on your own next. So our first example here is to find the value of x. I want you to go ahead, referencing the last example that we just did, and then submitting your answer into Edpuzzle. So now we're going to be working with arcs and arc measures, kind of just like how we have triangles. We have acute, obtuse, scalene, all those different types of triangles where an acute triangle has angle measures less than 90, an obtuse triangle has angle measures greater than 90. Same thing with a circle, except now we're going to be working with arcs. So arcs are, you start at your angle, and your arc is the outer edge across from your angle. So notice here, this is my first arc. It's called arc AB, and it is labeled as such here. We use this little arc symbol over our variables. And a minor arc is the shortest arc connecting 2 endpoints in a circle, and the minor arc's measure is always less than 180 degrees. That's not what I want to do, sorry. A major arc is the longest arc connecting 2 endpoints on a circle. your major arc is greater than 180 degrees and equal to 360 minus the measure of the minor arc with the same endpoints. So our major arc right here, you would start at A, and we're traveling all the way to B. Usually with major arcs, we have to use 3 different variables to name them. So going in order, I would say A, D, B is this major arc. And we have our arc symbol right there as well. And our last example is a semicircle, which we kind of already went over. It's really just half the circle and it measures 180 degrees. So please take a second and write this down in your notebooks. WC is a radius of circle C. You identify arc XZY as a major arc, minor arc, or a semicircle, and then we have to find its measure. So there was no option for me to use the little arc symbol, so you can also name arcs by writing it just like this, arc XYZ, that's fine. So arc XYZ is going to look like this. Arc XYZ starts with X and travels all the way to Y, making sure we're hitting that point Z in the middle. Arc XYZ is a semicircle, therefore the measure of arc XYZ is exactly 180 degrees. It makes up exactly half of the circle. Again, WC is a radius of circle C, and now we're identifying arc WZX as a major arc, minor arc, or semicircle, and we have to find its measure. So looking at WZX, I'm going to label it here from you. WZX, it skips right over Y, and that's fine. We're going to go straight to that point Z and end at X. And then we're going to try to find its measure. So arc WZX is a major arc, considering it is larger than a semicircle and less than a full circle. It is clear that this major arc takes up exactly 3/4 of the whole circle. Also notice we have a right angle right here that is not a part of our arc. So we know that this arc is 90 degrees, meaning that the remainder of my arc is going to be 360 minus 90, or 3/4 of 360, which is going to get me 270 degrees. In our last example here, we are now identifying arc XW as a major arc, minor arc, or semicircle, and we're going to find its measure. So XW is this arc right here. Notice that it is a minor arc because its measure is less than 180 degrees. And since the angle XCW is a right angle, the measure of XW arc, our arc there, is 90 degrees. So I'd like you to go ahead and try this example. LP is a radius of circle P. Identify arc LNO as a major arc, minor arc, or a semicircle, and then find its measure. So I want you to write this in your notebook. Find the measure of LNO. If you need to draw it and label the arc, go ahead and do that. And then submit your answer to Edpuzzle. We're going to be working with congruent arcs. So in the same circle or in congruent circles, 2 minor arcs are congruent if and only if their central angles are congruent. And we're going to see what they mean by this. So if angle 1 here and angle 2 here are the same measure, that would mean that arc FG and JH are also the same measure. Likewise, if arc JH and FG are the same measure and you're given that information, we can also assume that angle 1 and angle 2 also have the same angle measures. So here's some examples. We're going to find arc measures and circle graphs. So we're going to refer to the circle graph to find the measure of arc KL. Arc KL is a minor arc because it takes up 21% of our circle there. The measure of arc KL is equal to the measure of angle LPK. So we're looking at arc KL right here, and it's going to be the same exact measure of whatever LPK is. The measure of angle LPK is 21%, therefore arc KL is equal to 21% of the circle. So to show some math for this, we have to find 21% of 360 degrees. So you're going to set up your equation as the measure of angle LPK equals 0.21. That's how you convert percentages into decimals. So 0.21 times 360. The measure of angle LPK is going to be 75.6. Therefore, the measure of arc KL is 75.6 degrees. Pretty straightforward, pretty simple. Similarly, we have another example where now we're finding the measure of NJL. So we're starting at N, working our way around the entire circle. So starting at N, moving over to J, and finishing off right at L. So we have this whole piece of the circle right here that we're working with. Arc NJL is a major arc. This represents all types of bicycles bought except for this piece right here, which is our hybrid and our other. So NJL makes up youth bicycles, mountain bicycles, and comfort bicycles, but it does not make up this section right here because it's not part of our arc. So arc LMN represents 16% of the graph. So this smaller arc right here represents the other types, so other and hybrid, which is the opposite of what we're looking for, which is 16% if you add 9 and 7 together. This means that our larger arc is 100% minus 16%, which means NJL is 84%. You can also find this by adding 26%, 37%, and 21% together because it's made up of our arcs. So we need to find 84% of 360 degrees. So arc NJL is going to equal 0.84 times 360. So arc NJL is going to equal 302.4 degrees. And again, you could also add up all the percentages for arc NJL and still get 84% if you didn't want to subtract 16 from 100. So now I'd like you to take a shot at it. Here's a different circle graph, and I'd like you to find the measure of arc BC. Once you do, I'd like you to put that right into your Edpuzzle, please. Again, here's a second example. This time I want you to find the measure of arc ACB. Once you find that, I'd like you to submit that into your Edpuzzle as well, please. Next, we're going to be working with adjacent arcs. Remember, adjacent meaning next to. So the measure of an arc is formed by two adjacent arcs is the sum of the measures of the two arcs. So that sounds very confusing. So we're just going to do some examples together. Our first example here tells us to find the measure of arc LHI in circle M. Notice arcs LH, so we have LHI here. Notice arcs LH, HI, and IJ together make a semicircle, therefore equaling 180 degrees. We can use this information to find the measure of the missing arc LH. So we're going to work with only half of our circle here because we're given that this is 90 degrees by the right angle. We're given this is 32 degrees. So it's easier to work with the semicircle to find this missing piece here. So we're going to set this up as arc LH plus arc HI plus arc IJ equals 180 degrees. We're going to go ahead and substitute the values that were given. So we're looking for our missing arc LH. We're going to add 32 degrees plus 90 degrees to equal 180. 32 plus 90 is 122. Subtract that from 180 and we find that our missing angle here, our missing arc, is 58. So now that we have that information, we can find LHI because we have arc LH and we have the measure of arc HI. So the measure of angle LMH equals arc LH and the measure of angle HMI equals arc HI. So we can go ahead and plug that in. So the measure of angle LMH plus the measure of angle HMI equals arc LHI. So 58 plus 32 equals the arc that we're looking for. So that means our arc right here is exactly 90 degrees. A similar example, now we're going to find I, J, K. Notice that arcs HI, IJ, and JK together make a semicircle, therefore equaling 180. It's way easier to work with semicircles than with the full circle, so I recommend that you try to do that when you can. In order to find AJK, we need to find our missing arc JK here. This should not say LH, that's a JK, that's my fault. So we're looking for IJK, and we need to find our missing arc JK. We can also notice that arc LH is equal to the measure of angle LMH, and arc JK is equal to the measure of angle JMK. These two measures across from each other are vertical. So because we have vertical angles, we know the rule that vertical angles have congruent angle measures. So we just found in our previous example that LMH is 58 degrees. So that also means that angle JMK, this angle right here, is also going to be 58 degrees. We can use that information to find our entire arc. So we know that arc IJ plus arc JK is going to equal arc IJK. These angles that correspond with them, we have 90 and 58. We just found that through our vertical angle. And that's going to equal exactly 148 degrees. So this entire arc right here equals 148 degrees. I'd like you to try an example on your own, please. You're going to find the measure of arc EAB. You're going to find the measure of arc EAB in circle F. Write this down in your notebooks, try it out, and submit your answer into Edpuzzle. Similarly, for this example, you're going to find the measure of arc BCD. So you can use the example that you just wrote in your notebooks to try to find the missing arc here. Once you have, submit your answer into Edpuzzle. So finally, we're going to be working with arc length. The ratio of the length of an arc L to the circumference of the circle is equal to the ratio of the degree measure of the arc to 360 degrees. So our equation here is going to be the arc length. The length of this entire arc is going to equal whatever the central angle is here, divided by 360 times 2 pi r, which is our circumference. So a quick example, we're looking for the length of arc DA. And we're going to round that to the nearest hundredth. We're going to use our equation here to try to solve that. So I went ahead and plugged it into the computer. So we have L, which is arc length, equals our angle measure divided by 360 times the circumference. I'm going to plug in and substitute my values. So L is going to equal 40 divided by 360 times 2 pi times 4.5, because 40 is my angle measure that I'm given and 4.5 is my radius. I'm going to simplify my equation. So once I divide 40 by 360, I get 0.111. I'm going to multiply that by 9 pi, because 4.5 times 2 is 9. And once I solve that out, I'll get that my arc length is 3.14 centimeters. Pretty straightforward, pretty simple. Just another example to walk you through. This time we have a radius of 6, an angle measure of 140, and our arc length is DA. So we're no longer looking for the measure of the arc, we're looking for the length of the arc, which is why we need this formula. So we're looking for the length of DA. So the measure of DA is 140 degrees, but the length of it's going to be a different number. So we're going to use this equation again. So I have the arc length is going to equal the angle measured divided by 360 times our circumference. I'm going to go ahead and substitute in those values. So I have the arc length equals 140 divided by 360 times 2 pi times the radius, which is 6. I'm going to simplify this information. So I'm going to get the arc length equals 0.39 times 12 pi. And I'm going to solve that out to get the arc length is 14.66 centimeters. Please make sure you're writing this all down in your notebooks. Here's an example for you to try. You're going to find the length of arc JL, and I want you to round that to the nearest hundredth. Draw it into your notebooks, do the workout, use your equation that you were just given, and submit your answer into Edpuzzle. Once you've submitted your answer, that's the end of our slides. So it's very, very important for you guys to recognize that I am providing you the slides, I'm providing you the information, so please don't watch the Edpuzzle and just go through it and click whatever answer. Really put in the work. Have a notebook in front of you. Put the examples down. Write all your work out. Reference your notes when you're going to complete the Google Forms that I'm going to assign later in the week. Please make sure you're giving this 110% because that's the only way that this is going to work. There's only so much I can do at my end. If you're not attending the Zoom meetings, you're really missing the reinforcement of the content. So it's really, really on you, and it's very, very important to write down every single part of the slides that you can and all the examples because that's what's going to help you. Good luck, everybody, and I will see you at our next Zoom meeting.